And we're live. All right, everybody, welcome into another live stream. This is Dr. Andrew coming at you. Today is November 5th, 2025. We're going to get our poll up and active today. Let's get 40 minutes on the clock today. What topic should we focus on? We're going to say A, Gen Chem, B, Organic Chem, C, Physics, or D, Calculus. 40 minutes are on the clock today. Johan, welcome in, first one in. Guys, make sure you tap on the screen, tap the top left hand corner there, and select the result today. Brian, welcome in. Scene, welcome in. Sammy, welcome into the chat. Guys and gals, we're going to wait about 5 or maybe even 10 minutes before we get started today. And let me know down in the comments, what topic should we focus on? Is it going to be A, Gen Chem, B, Organic Chem, C, Physics, or D, Calculus? All right, and so again, make sure you vote on the top left-hand side of your screen. Thank you, Sammy. Guys, we're going to wait just a few minutes for folks to chime in, and then we'll get started right away. How's the semester going for y'all? It is officially November. This is my first stream of the month. Personally, I really love November because it is nice and cold. And we are going to do our live streams every single week. And so, guys, we're going to try to ramp it up because I know finals are coming up very soon. When do you all have finals? Is it going to be in the end of November or the beginning of December? Let me know what finals you guys have. That was going by quick. I don't know about y'all, but I thought that was going by really quick. Sammy says, Chem is cooking me. Oh no, what chem are you taking? Is it general chemistry? Okay, guys, we got 1 vote for physics. Thank you. Got 1 vote for calculus. Guys, we're going to wait about 5 or 10 minutes before we get started because quite honestly, I don't know what to work on today. So make sure you drop your comments down below. Make sure you vote up on the top left-hand side of your screen. If you're new here, comment the word new so that we know that you're new. And we'll get started in a bit. Guys, I've been pretty busy lately, so I just posted a physics video where I went through several practice problems, so you can check that up on my YouTube channel. Just posted that earlier today. Reactor kinetics, period. Okay, we gotta do some chem engineering. Guys, make sure you vote up on the top left here. Okay, make sure you tap on the screen. Tap on the top left hand side of the screen, and then we're gonna go ahead and get started. Now the only thing is, like, sometimes people vote and then they dip, so it's like, okay, if you can't make it, then don't just don't vote because you can't stay. All right, Sammy says, I'm taking Gen Chem but also learning OChem at the same time. Ooh, awesome. How's that going? Is that making sense for you? Are you able to understand the organic structures? Thank you for voting. THY says A. Guys, remember, make sure you vote on the top left-hand side of the screen, okay? TikTok is not going to register your vote unless you actually vote. So we got 2 votes for physics, so maybe we'll get started with physics today. And we got 1 vote for calculus, so maybe we'll get started with physics today. But again, make sure you tap the top left-hand side of the screen, otherwise it won't go through. There we go. All right, got another vote for chem and another vote for physics. Guys, we're going to wait about another minute before we fully get started. Oh, you're on the laptop. Okay, got you. Got you. Egg roll, Gen Chem. So again, egg roll, make sure you tap the button. Tap the vote button. Guys, if you're new here, comment the word new so we can welcome you in. If you're new here, comment the word new so we can welcome you in. We're going to get started in about 1 more minute, and then we will get ourselves situated. Jumping right into it. Seems like physics is cooking right now, so I think that's going to be the first thing. So comment the first physics topic we should work on, chat. Is going to be kinematics, vectors, Newton's laws, force body diagrams, centripetal acceleration, centripetal motion. Is it going to be velocity? What is going to be the first topic we got to do? Because it seems like physics is cooking up. Saeed says vote general chemistry. So if you want to invite your friends, make sure you invite your friends to vote so that your topic can win. We got 3 votes for Gen Chem, 3 for physics. Right now, physics is cooking. How do you vote? Wani says new. You vote by tapping the top left-hand side of your screen where it says the vote button by TikTok. Hess says circuits. It's a checkbook icon on the top left. All right. Cool. Oh, it seems like GenChem just took over. So, guys, we're going to get started in about 15 seconds. GenChem is suddenly cooking. I thought we were going to do physics, but then it seems like GenChem is cooking all of a sudden. Guys, welcome into the chat. And let's get started now. All right, so let me pull this up here. Just wait a couple more seconds. Guys, make sure you tap the screen, invite your friends to the live, drop your questions down below. All right, everybody, so welcome into the chat. Oh, we gotta hide this and bring this up here. All right, welcome into the chat. My name is Dr. Andrew, PhD in Chemical Engineering. If you're new here, where's my picture? Hold on a sec. Where's my picture? There we go. If you're new here, comment the word new so that we know that you are new. And if you've been here before, comment that lock emoji because you know we're about to lock in. So get out your notes, get off your bed, stop scrolling on your bed, and actually follow along because I guarantee that if you actually follow along and do the calculations, you're going to learn a lot today. Guys, once again, welcome into the chat. We are just getting started for today. This is Dr. Andrew coming at you with another live stream. I do go live every single week, Monday through Thursday, to answer your STEM questions. You can either drop them down below or drop them up on the Discord. If you want to join the Discord, it's totally free. Just go to my link in bio, engineeringminds.co. Click that link that says join Discord, and that's going to be the best place for you to drop questions. You can also tap this link that says TikTok Q&A. That's going to be another place to drop questions, okay? So go to engineeringminds.co where you can drop your questions and explore resources. So if you tap on this resource page, you're going to see everything you ever need for mathematics, physics, chemistry, engineering, computer science, and more. And last but not least, if you think you need tutoring, I got you for various STEM subjects. Again, I do have a PhD in chemical engineering, and right now I'm tutoring for Gen Chem, math, OChem, physics. If you're in engineering, if you're in AP Chem, AP Physics, you can sign up for a free consultation call by tapping that link in bio. And again, you can join the Discord, which is totally free, and sign up for tutoring here. And we're going to get started right away, chat. Okay, we're going to get started today. Guys, once again, the poll is active. We got 30 minutes on the clock, so it's not too late to vote. But we are going to get started with our winner currently is Gen Chem. So if you want to vote, make sure you invite your friends to the live. Make sure you tell all your friends, hey, vote for whatever you want to go over, okay? If you have your classmates in Gen Chem, you're going to vote for A, Gen Chem, B, Organic Chem, C, Physics, D, Calculus. Okay, so it seems like Gen Chem is cooking. So make sure you comment down below what topics in Gen Chem you would like to go over, okay? Make sure you comment down below. So we're going to start off with Gen Chem, but it's not too late. Still got 32 minutes on the clock, okay? So invite your friends to the live so we can all vote. All right, so what's going to be the first topic for Gen Chem, my friends? What's going to be that? What's going to be the hardest thing that y'all are working on? Is it going to be stoichiometry? Is it going to be molarity? Is it going to be solution stoichiometry, acids and bases? What do you want to go over today, my friends? This is a live Q&A. Just drop your questions down below. I'm going to go one at a time here. Okay. So got calorimetry, thermochemistry, electrochemistry. We got 2 for electrochem and 2 for thermo. And then 1 for acids. Jared, good to see you. Dano, thank you for the follow. Do you tutor for the MCAT? Yes, I tutor for the MCAT. And sorry if I missed your question earlier. And then quantum theory. Okay, so I think what we're going to do, thanks for 1K likes, Saeed, appreciate y'all. I think what we're going to do is part 1, we're going to do calorimetry for the next several minutes. We're going to do calorimetry here to get started off, and then we're going to do electrochemistry. So guys, once again, get out your notes, get off your bed, don't keep scrolling, okay? Don't keep scrolling. Make sure you lock in. So guys and gals, one more time, this is Dr. Andrew Sanchez. If you're new here, comment the word new so that we can welcome you in. And if you are about to lock in, comment that lock emoji. We're about to lock in for our first topic for today, calorimetry. We are just about to get started here. So if this is a good topic for us to go over, comment that lock emoji to let us know that you're actually going to lock in. Try to follow along as best as possible, okay? I promise you're going to learn as much as you can here. All right, it says I'll be back for electrochemistry. Thank you. So the first thing we have to go over is going to be this equation here. this equation here is going to be Q equals mCp delta T. All right. So let me get my notes here, chat. Let me get some notes here so I can follow along here. So we're going to get started on our first topic for today. This is going to be calorimetry, and whether or not you're in AP Chem or college chem. First of all, chat, let me know whether you're in AP Chem or college chem. Are you in high school chemistry or general chemistry in college? And don't worry, if you're in high school, I'm going to try to break it down as easy as possible. And if you're in college, I'm going to make it I'm going to teach you everything you need. So whether or not you're in high school or college, we're going to break it down so that everyone can learn here. Okay, so someone says AP, Diamond says college chem, Alice says college chem, high school, gen chem, high school. So we got a mix of high school and gen chem in college. So again, I'm going to teach you guys both at the same time. Okay, I'm going to teach you guys both at the same time. So this is the main equation I want you to understand here for calorimetry here. This is the main equation I want you to understand for calorimetry here. So Q is going to stand for heat, okay? Why is Q heat? I don't know. I don't know why they chose Q. Q is really random, but they just chose Q here, okay? Yeah, we can definitely do calculus, but make sure you vote on the poll, Twin. I'm in AP Chem. Can you go over stoichiometry after this? Twin, I do have some stoichiometry videos on my YouTube channel if you want to check that out. And so delta Q is going to stand for heat, and it's measured in joules. Okay, chat, what is the mass going to stand for? Oh, whoops, I just gave it away. Huh? Whoops, what is M going to stand for? What is M going to stand for in the equation Q equals mCp times delta T? So who knows what M stands for? Okay, cool. M is just going to be the mass. So hopefully everyone's familiar with that. That's just going to be in grams. What about this CP term? What is going to be the CP term? So what's going to be the CP term? Again, this is going to be the most important equation you need for calorimetry here. Okay, what is going to be the CP term? Anyone know? Heat capacity, perfect. So now that CP term is going to be known as the heat capacity. So what is the physical meaning of the heat capacity? So if something has a high heat capacity or low heat capacity, what does that actually mean? Okay, what is that actually going to mean? Okay, you might also heard this called specific heat. Okay, or molar heat capacity or specific heat capacity. Okay. Excuse me if I'm American. Heat isn't in joules. Heat is a form of energy. It should be in joules. Okay. Child pizza? No. Okay. Okay, what it boils at? All right, kind of. Someone said gang no. So it's gonna be the measure of energy that it takes to change one. It's gonna be the measure of energy. Let's write this down, chat. Heat capacity is the amount of energy. Okay, energy required to. Okay, remember, chat. Remember, gotta stay locked in here and take out your notes and write this down, okay? Because this is the most important thing you need to understand for a heat capacity here. Required to change 1 gram of a substance, 1 gram by 1 degree Celsius, okay? By 1 degree Celsius. So, therefore, the units for heat capacity better be in joules per gram degrees Celsius, okay? And right off the bat, I want you to memorize one of these values here. The heat capacity for water, you got to memorize this, chat, is what? Does anyone know the heat capacity for water? If you're in AP Chem, you don't need to memorize it. Your teachers are going to give it to you. But if you're in college chem, you better memorize it because sometimes they do or not give it. They may or may not give it to you. Exactly, 4.184. So again, if you're in high school, you do not need to memorize this. But if you're in college, you better memorize it because you're going to use this so much that you better start memorizing it. Cool. So are we good on heat capacity so far? Let's see. Drop a thumbs up if we're understanding the heat capacity so far. Joules per gram degree Celsius. Okay. So that's going to be the heat capacity. Cool. All right. And then last but not least, we're going to have delta T. So make sure you put this little triangle here. So guys, don't start freaking about the little triangle here. So what is the triangle going to indicate? What is the triangle going to indicate? So if I put delta X, what does that indicate here? And if I put delta T, what does the triangle indicate? There you go. Change in temperature. Very good. Very good. So delta here, this is the Greek letter delta. Don't even start freaking out. As soon as you see delta, it's just going to be the final minus the initial, chat. Okay, just stay locked in with me here. Don't even start freaking out as soon as you see that. Okay, therefore the delta T is the change in the temperature. It's going to be the final minus the initial temperature. So delta T is the change in temperature here. Okay, so that's the equation here. That's the equation here. Okay, and that's going to be typically in degrees Celsius or Kelvin. Okay, so that's going to be the main equation here for calorimetry. Let me know if there's any questions here. Let me know if there's any questions for calorimetry. Drop them down below. If we're understanding this so far, go ahead and drop a thumbs up. Okay, if you're understanding this equation, go ahead and drop a thumbs up. If you want to see some examples, comment the word examples. Okay, if you want to move on to a different topic, comment move on. Okay, if you want to see some examples for calorimetry, comment example. Okay, if you want me to do a worked out example, or if you're feeling bored already, you want to move on, comment move on here. Okay, Alice says examples. Teeter says examples. All right, cool. So everyone wants to see some examples. Perfect. So the x was just an example. X is a random variable. Okay, you're not going to do x. You're going to do the change in temperature. So our first example here, our first example is going to be to calculate. We're going to calculate the heat needed. How much heat is needed? How much, let's just say how much heat required to warm 250 grams of water, okay, from 22 degrees Celsius up to near its boiling point, 98 degrees Celsius. Okay, and so perfect. Okay, so we're gonna use this this temperature here. Okay, so Nate says move on, Ryan says example. Okay, we got a couple for move on, so we'll do a couple examples here. All right, so cool. Now this is gonna be our gotta give it to us in milliliters, so it's still like in density. Ooh, that's a fun one. Okay, let's do that real quick. Let's change the problem up. Let's change the problem up here, okay? So we can do a little bit of review. So let's do, give me a number here, chat. Give me a number here, 1 through 100 here, a random number. And so we're gonna calculate the heat required to warm up some volume of water, okay? Yeah, I'm gonna go over enthalpy. That's crazy. I was actually thinking of 67 as well. Okay, we all know why. Okay, that's crazy. We all know why, but I was actually thinking of 67 as well. So we're gonna calculate the heat required to warm 67 milliliters of water from 22 degrees Celsius to 98 degrees Celsius. So I'm gonna draw a picture here, and then here's our cup of water. Bro, they updated GoodNotes, and now I can't draw perfect squares anymore, which makes me a little bit angry. So this is gonna be our 67 milliliters of water. Now I do want you to memorize, chat, that the density of water is 1 gram per milliliter. So I have 1 gram per milliliter here. All right, and so what's the first thing we're gonna do, chat? So if we have 67 ml, and then we need to calculate the heat required. Okay, so Ludi says, how do you know if Q is negative or not? All right, we're definitely going to go over that. We're definitely going to go over the positive versus negative. Okay, cool. So thanks for that. So guys, what's the first thing we need to do? Remember, it says we have to calculate the heat required. So what's the formula for heat? Okay, what's the formula for heat? We just went over that. Heat, Q equals mCp delta T. Okay, so we need M, but we don't have M anymore. I gave you M a second ago, but then someone suggested, all right, let's get volume. So first things first, I need to convert volume into M. So first things first, I need to get volume into M. So how do I get grams? How do I get grams from the volume here? So I'm going to start with what I have here. I'm going to start with 67 milliliters of H2O, right? 67 milliliters of H2O. And then I'm going to do, all right, 67 milliliters, okay? I'm going to do times 1 gram per milliliter. Guys, that's going to be the same exact thing here. So that's going to be literally 67 grams, okay? Cool. Q equals MCAT. Yes, I forgot to mention, the way you memorize that is Q equals MCAT. What the heck is MCAT? MCAT is an exam that you have to take if you want to go to med school. So that's the best way to memorize that. Q equals MCAT. So now we have 67 grams, chat. So now we're going to use Q equals MCAT. Okay, so Q equals MCAT. So I'm going to start to plug it in. So now I have my M. Remember, my M is already 67 grams here. Okay, and then what's going to be the heat capacity? What's going to be the heat capacity? There should be a CP over here. What's going to be the heat capacity of water? Remember, you have to memorize this 4.184. Can you do physics later? Guys, if you want me to do physics, make sure you vote up on the poll, guys. It's not too late to vote. You have 20 minutes to vote up on the poll. Okay, invite your friends to the live and tap the screen on the top left-hand side and invite your friends so you can get over whatever you want to go over. And if you want to do physics, I just posted a physics video on my YouTube channel, chat. Okay, so guys, now we have Q equals MCAT. So Jared said we rounded the 1 gram per milliliter. Technically, this is 0.97. I'm going to leave it as 1 just for simplicity here. And then we have delta T. Okay, so how do we get delta T, chat? How do we get delta T? So it says the heat required to warm 67 ml of H2O from 22 to 98. So from 22 to 98, right? From 22 to 98. So how do I get my delta T? Remember, delta means change. Delta means change. And so I'm going to take my final minus initial here. So I have my T final minus T initial. So my final temperature was 98 Celsius minus the initial was about room temperature, that was 22. So someone go ahead and please calculate what is 98 minus 22. What is 98 minus 22, chat? That should be approximately, I'm locking in for the math for a sec. I'm like kind of struggling with the math. That should be 76, right? That should be 76. Here we go. So that's delta T equals 76 degrees Celsius here. So that's going to be our total MCP delta T. So I'm going to plug that in. Okay. So guys, remember, this is why you have to log in, because I'm not going to give you the answer this time. I need you to actually calculate this. So I'm not going to give you the answer. I'm going to have you actually get out your notes, get out your calculator. Let me know what is the final answer. Let me know what is the final answer. Okay. So we can leave that all here in degrees Celsius. So someone go ahead and calculate that out here. Okay. Someone go ahead and calculate that out. This is going to be in joules here. Okay. So someone calculate, what is that value? 67 times 4.184 times 98 minus 22. Okay. So someone said 84.57. Okay, so 958 says 84.57. So let's see if they're right here. Let's see if they're right. We got to say basically 67 times 4.184 times 98 minus 22. So I got a really big answer, chat. Okay, I got a really big answer. I think that is a little bit incorrect, my friend. Okay, something is wrong. There is not 84. Try again, chat. Try again. So what is 67 times 4.184 minus times 98 minus 22? Okay, try that again. So it's going to be a really big number. So 67 times 4.184 times, don't forget your parentheses here, 98 minus 22. Try again, chat. You guys got this. You guys got this. Okay. So, oh, well, we got grams per milliliter. Let's see. Someone said convert to liters. Someone said convert to liters. No, we don't got to do liters, chat. We got to do grams here. There you go. There you go. Got 20,000. Okay, I got something a little bit different because I'm rounding. So I got 20,795 here. Okay, someone said 21,000. That's probably gonna be more accurate. Okay, because I was rounding all my numbers here. So as long as we're in the ballpark, that should be good here. Okay, and then we're gonna just divide by 1,000 because we want to convert this to kilojoules. Okay, and then I'm just gonna round that up here. So that's gonna be approximately 20.8 kilojoules, approximately 20.8 kilojoules. Okay, so this is the amount of energy it requires to heat up the water here. Okay, so this is the amount of energy it requires to heat up the water. Guys, let me know if this example was helpful. Okay, drop a thumbs up if you're still following along here and you are actually making sense of this. And let me know if you're not mega cooked here. If you're mega cooked, drop that crying emoji if you have no idea what's going on here. Okay, Alina says thumbs up. Alina says thumbs up here. And then let's see how we're doing here. So that was our first example, chat. Okay, and again, I am recording this so you can watch this into we watch this on YouTube after. How do I convert it to joules? Our answer was in joules to win. So our answer was in joules. I converted it into kilojoules here. So our final answer was in joules, and then I divided by 1,000 here. Okay, just got here, show the top. Okay, so let's do a quick recap of our very first example on calorimetry. So we're gonna do a recap on calorimetry. The equation for calorimetry is the heat equation. Heat is given by the letter Q, and that's equal to mCp delta T, where heat is measured in joules. M is the mass of a substance in grams. Cp is the heat capacity, which is the amount of energy required to change 1 gram of a substance by 1 degree Celsius, whereby the heat capacity of water is a constant 4.184 joules per gram degree Celsius, and delta T is the change in temperature. So for instance, what we just did was we calculated the heat required to warm 67 ml of water from 22 degrees Celsius to 98 degrees Celsius. Okay, so they gave us 67 ml of water and the change in temperature from 22 to 98. However, we don't want ml, we want grams, guys. Here we have mass is in grams here. All right, and so then what we have to do, guys, is basically use the equation Q equals MCAT, plug that in. At the end of the day, we have 67 grams, okay, times 4.184 joules per gram degree Celsius, times another 98 minus 22, and that's going to be our final equation here. Okay, so yes, someone said 67, and then we got to do this today. Okay, someone said mega cooked. This section happened in August 6-7. Okay, guys, so welcome into the chat. This is our very first example today. I think the next topic is going to be Hess's law, because someone said show enthalpy. So guys, if Hess's law is a good topic, make sure you comment a thumbs up for Hess's law. If you think Hess's law is a bad topic, you want to do something else, comment a thumbs down or a crying emoji. But before we do, make sure you vote up on the top left-hand side of the screen. What's the topic you want to work on today? We go live every single week to answer your STEM questions. So make sure you hit that follow button and invite your friends to the live stream. Tap the top left-hand side of your screen is going to be A, Gen Chem, B, Organic Chem, C, Physics, or D, Calculus. We're going to go on for another hour and a half, so it's not too late to drop in your questions down below. Okay, and then what we're going to do is basically talk about, let's see who's cooking right now. So we got about 12 minutes left on the clock. Gen Chem is still cooking it up today, so it seems like we're going to be doing Gen Chem unless OChem makes a comeback or Physics catches up. Okay, Physics was doing good as a close second, but now Gen Chem is cooking it up here. All right, so guys, we are going to keep going. I see that people still want to go over heat energy and calorimetry. So that was calorimetry in a nutshell. So we're going to go over Hess's law next. So guys, remember, get out your notes, get off your bed. Do not just blindly watch this. You're not going to learn just by scrolling on your bed. I want you to actually get out your notes and your calculators and follow along. Okay, that's going to be the best way to understand this. So we're still in the regime for energy, but I'm gonna give you an equation here, and we're gonna break down this equation. So Hess's law says that the delta H of a system here, okay, delta H of a system is given by it's gonna be given by the sum of the stoichiometric coefficients times the H of formation of the products, okay, minus the sum of the stoichiometric coefficients times the delta H of the formation of the reactants. Okay, so guys, this is the true equation. Okay, if you understand the true equation, that's fine, but I'm gonna give you the easy version so that way we don't get confused. Just memorize this equation, guys. Delta H equals products minus reactants. There we go. That's way easier to understand. Okay, don't worry about the true equation if you don't understand it. Okay, if you understand it, that's great, but if you don't understand it, that's totally fine. I want you to realize delta H, okay, is given by products minus reactants. What's up, Charlie? Okay, so this is going to be our delta H total here. Okay, So someone also suggested gases. We can do gases as well. We haven't done gases in a while. Maybe that will be next. So guys, this is gonna be the way easier form. So now, what does delta H stand for? What is delta H going to indicate? If you've been here before, this is something we talked about before. So what does delta H indicate, chat? Okay. Is this Chem 1 or Chem 2? I'm not sure, chat. Is this Chem 1 or Chem 2? I want to say this is right in between Chem 1 or 2. So this is going to be basically, someone said, can we do Roblox? This is basically going to be like at the end of Chem 1 or at the beginning of Chem 2. Okay. So delta H is going to stand for what here? Okay. H is going to stand for enthalpy. H is going to stand for enthalpy. So what is enthalpy, chat? What is enthalpy? And it's really going to be the change in enthalpy. So don't even worry about what enthalpy is. Just think of enthalpy as basically heat. Change in enthalpy. Okay? It's basically heat. And don't let your chem professor hear me saying that, okay? Because it's not really heat. Okay, but we're gonna say the word basically heat. Okay? So don't tell a thermodynamicist that enthalpy is heat. Okay, they're gonna flip out here. Okay, but it's basic, just for your sake of understanding, just to make it really easy, guys. Don't overcomplicate Gen Chem. Okay, it's basically just heat. So for example, if I have a reaction where I'm mixing sodium hydroxide, okay, if I have sodium hydroxide plus water, okay, it's gonna get hotter. Okay, it's gonna get hotter. So I'm gonna create a positive. I'm gonna create positive. I'm gonna create positive. It's gonna create energy here. So it's going to get hotter. Okay, it's gonna get hotter. So if it gets hotter, is it absorbing heat or is it producing heat? If something is producing, if something gets hotter, okay, let's do a quick chat. Let's do a quick poll. So if something is getting hotter, is it producing heat or absorbing heat? Let's do a quick poll. If you think that this is going to be producing heat, you're going to drop a happy face emoji. If you think it's going to be absorbing heat, you're going to drop a crying emoji here, chat. So go ahead and just drop a comment down below because we have that poll active. So just comment if you think it's producing heat, and we know that sodium hydroxide in water is getting hotter. Comment a happy face emoji. If you think it's absorbing heat, comment a crying face emoji. Remember, the key word is getting hotter here. Okay, so while you guys are discussing that, let's draw a picture of what that might look like. Okay, so one day Mr. Heisenberg was working in the lab and he accidentally dropped some sodium hydroxide in some water, and then the sodium hydroxide started getting really hot. Okay, so now this is a really hot solution of sodium hydroxide. So is the delta H, if it's getting hotter, is it producing heat or absorbing heat? Okay, we got Christy S, Franco producing, my biochem, MN, Leslie, happy face. We got a really healthy mix of happy face and crying emoji. So I wish we could do the poll, but we're still doing the main poll here. So guys, the correct answer here, guys, is if we're producing, if we're getting hotter, then that means that energy is being released. Okay, that means energy is being released. Okay, if you touch this here, okay, so that means we are producing heat here. Okay, so everyone go ahead and drop a thumbs up down below if you got that correct. Drop a party emoji or a woo woo hands up emoji, because we are getting hotter, so that is producing energy, right? Okay, so if you said absorbing, you probably thought the opposite case. So that means that we are releasing energy, and that is what delta H is going to indicate. Okay, that's what delta H from our term for enthalpy is going to indicate. Now, if something is releasing energy, we're going to say that delta H is negative, and there's a term for that. So if delta H is negative, what is the term for something that has negative enthalpy change here? Okay, if delta H is negative and we're producing heat, that's going to be called exothermic here. Okay, so if delta H is negative, that's called an exothermic reaction. We're releasing energy here, so it's going to get hotter. Okay, so I always used to mess that up. I always thought it was the opposite. Contrarily, if something is absorbing heat, it's going to be called endothermic. Okay, it's absorbing energy. So the way you can think of it is like a box. Okay, and think of it as like a box. And then if our energy is going in, we're going to represent that as a Q coming in. And then if we have Q coming out, we're going to represent that as a Q coming out. So this is exiting. So exo means exiting, okay? And then endo is entering. So that's why we have exothermic is exiting, and then endo is going in. Does that make sense, chat? Does that make sense here? Drop a thumbs up if we are so far so good here and we are following along for Hess's law. And if you got cooked here and you got a little bit lost, drop that crying emoji. Okay, drop that crying emoji. I'm going ahead and checking the chat here. So Lyanne says happy face, diamond, party emoji, Leslie, party emoji, hands up. Okay. Bro, I'm gonna need you to do a YouTube channel and teach this for real. Okay, I do have a YouTube channel, but I do need to lock in, guys. So you can sub to my YouTube channel. Okay, it's the same as my TikTok. But yeah, I just need to lock in and just post more. Okay. Yeah, of course, JDL. Thank you for that. All right, Lion says thumbs up. So far, so good. Leslie, thank you for the wow. What is that? That was new. Okay, thank you for the budding heart. I'm not sure what that was, but I appreciate it. Can you do the Maxwell relation for enthalpy? Okay, guys, we're gonna do a quick side note. We're gonna do a quick side note for engineering, and this is not required for Gen Chem. This is only gonna be for engineering because someone asked an engineering question, and I can't deny that real quick. So, guys, let's do a quick side note. So, if you're in Gen Chem, you're allowed to log out for a sec. This will not be required here. So, let's just do a quick side note for engineering. And the Maxwell relation is going to be, we're going to have H equals U plus PV, okay? And we're going to basically take the derivative of both sides here. So guys, this is not Gen Chem. This is now a little bit of engineering here, just as a quick side note here. And this is going to be PdPV here. And this is going to be called the Maxwell relation here. Doing it from memory here, let me just look it up real quick. Maxwell relation for enthalpy. Okay, and if we do the product rule here, we're gonna have dH equals du plus pdv plus vdp here, and pdv is going to be called work. So we're going to define work as going to be negative pdv here. So the Maxwell relation should be the following equation, should be delta H equals delta U minus pdv plus VDP here. Okay, and that should be our main, that should be our first Maxwell relation here, if I'm not mistaken here. Okay, so guys, this is a quick side note for engineering. You do not need to know this. You do not need to know this for Gen Chem, but this is going to be what you're going to see if you're in chemical engineering or mechanical engineering, or if you're a physics major or if you're a math major. Okay, you do not need this for AP Chem or Gen Chem. This is only for a quick side note. And guys, let's do a quick check in the poll. Thank you, thank you. Love you back, love you back. So producing is exothermic, exactly. So producing energy is exothermic. And you can submit a question by dropping it in the website or on the Discord. Okay, so join the Discord, link in bio, and then shoot me a DM as over here. With respect to what? Good question. Well, we wrote these as differentials. So thermodynamicists write these as differentials. So we're going to just leave it with respect to whatever you want. So if you want to do dP, dV, ds, it can be with whatever you want here. Okay. So guys, what time are you going to switch to organic chem? Guys, let's do a quick check in the poll here because we still have about 2 minutes left. So we're going to keep it going here. We're going to do about 2 minutes left. Let's go ahead and see how we're doing here. What topic should we vote on? What topic should we focus on today? So we basically have Gen Chem, OChem, math, or physics. So the poll is still active, but there's only 1 minute left. So make sure you invite your friends to the live stream and go ahead and tap that poll up on the top left here. So let's see how we're doing here. Okay, we got 12 votes for Gen Chem and 2 votes for organic chemistry. Okay, OChem got cooked today, guys. Sometimes OChem cooks, but it seems like OChem basically got demolished today, which is fine. We can do that today, tomorrow. We got some votes for physics. Physics is a top second, and calculus is going to be third. So 1 minute left here, guys. 1 minute left. So during that minute, I'm just going to talk about my website real quick one more time. Go to engineeringminds.co where you can submit your questions, join the Discord for totally free, and sign up for tutoring, guys and gals. If you need any help, I got you for all these subjects. Okay, I can do private tutoring or group tutoring for mathematics, general chemistry, physics, and organic chemistry, as well as engineering. And guys, all my information is here as well. So you can see my TikTok link there, my Instagram, my YouTube channel. So I post all the live streams every single week now. And so that way you can never, that way you'll never miss another. So if you miss a live, you won't be able to, you won't fall behind. Okay, so guys, let's see how we're doing here. 5 seconds left, and the winner is gonna be Gen Chem today, guys. So Gen Chem pretty much just demolished. So we're gonna do Gen Chem for another hour and 20 minutes. I'm gonna go until 8 o'clock p.m. PST. And regarding the pricing, all the information is there on the website, and you can see the pricing there as well. So like partial derivatives, yeah, exactly. So I don't think I explained that very well. The partial derivatives are, you can basically use that, you can use whatever you want, guys. So if you want to differentiate with respect to H, P, V, or U, mathematically, you can do that with whatever you want. Okay, guys, so now we got to do another quick poll here. So I want to see how we're doing here. We're going to do another quick poll to see if we want to do the same topic, okay, which is basically thermodynamics, or we want to do another topic, which is going to be, let's see, we can vote here. So let me get that up real quick here. So we're going to do, are we going to do the same topic, chat, or a new topic? Okay, new topic. So I think the next topic, I promised was going to be electrochem. Okay, I promised was going to be electrochem. So we're going to do electrochemistry next. Okay, so guys, if you want to see the same topic, which is going to be thermodynamics, and doing more examples for Hess's law, then go ahead and vote for that happy face emoji in just a second. If you want to switch gears to electrochem, go ahead and comment that crying emoji there as well. Guys, bear with me one sec. Let me get my poll out. Hold on a second. Can you help me with a question from a Canadian math contest? Ooh, what kind of question is it? Okay, we're going to do a quick poll, so only 60 seconds up on the clock. And 60 seconds up on the clock starting now. There's no integrals in chem. No, this is not, we did a side note. This is not chemistry anymore. We just did a side note for engineering. We're going to jump right back into chem. Okay, we're going to jump right back into chem. So no, there's no integrals in chemistry, at least in first year chem. But yes, once you get higher into it, yes, there's going to be calculus, because chemistry is straight from physics and thermodynamics is definitely going to have calculus. Okay, guys, so right now we have 4 votes for still thermo. So it seems like everyone still wants to keep it going for thermodynamics and Hess's law. So let us continue that. And then, guys, we have 20 seconds left for the poll. So let's do our first Hess's law example then. Let's see how to apply what we just learned. We're going to do a Hess's law example. So again, I'm going to break it down as best as I can, whether or not you're an AP Chem in high school or college Chem. This is going to be understandable and helpful for everyone. So once again, get out your notes and get off your bed. Make sure you actually follow along, because I promise you, you are not going to learn by just blindly watching the TikTok, okay? You got to actually lock in, chat. So I'm going to give you a reaction here. I'm going to give you this reaction, and we got to get the total delta H here. So this is going to be our first reaction. Okay, so it says that carbon solid here, okay, plus O2 gas, carbon solid, hold on a sec, I'm gonna try that one more time, so hopefully we can see that, right? Carbon solid, okay, yep, plus O2 gas, okay, this is gonna be our first reaction, is gonna be CO2, okay, and then the delta H is gonna be given here. So the delta H will be given on this side here. And this is going to be in kilojoules. And so this delta H for this reaction is going to be the following. It's going to be a negative 393.5. So chat, is this endothermic or exothermic? If it's negative 393.5, is this endothermic or exothermic? Let me know down below. Okay, so exo, right? Good, good. It's exothermic. So how do you know it's exothermic, chat? How do you know it's exothermic? What about this equation here? So what about this equation here? This delta H is negative 283.0 kilojoules. So is this endothermic or exothermic here? Same question. Releasing heat. Good. Good job. Good job. Delta H is negative. All right. Everyone's cooking. Aha, cooking, because we are in thermodynamics. So we got to be cooking here. So this is going to be C solid plus 1/2 O2. Okay, 1/2 O2 gas. And this is our third equation. So this is going to be CO gas here. And we have to solve, this is our unknown. This is what we're trying to solve for here. So we need to use equation 1, okay? And equation 2, it's kind of like a puzzle. So we got to use what law, chat? What law are we going to use here? Okay, whose law are we going to use here to solve for this equation here? Okay, whose law here? We're going to basically use Hess's law. Okay, so for Hess's law, we have to basically do a little bit of manipulation here. Okay, because the negative, which is producing heat, exactly, right? Good, good, chat. Okay, good. Everyone's doing great so far. So we have to identify, let's see equation 1 here, and then equation 2. So I see that, what do we have to do, chat? What's the first thing we have to do? What's the very first thing we have to do? So notice that I have my 1/2 O2 right here. So I have a 1/2 O2 right here. So that's really good. That's really, really good, chat. So let's make this as big as possible. Is that the biggest I can make it? Okay, so here's my 1/2 O2. Okay, and then here's my 1/2 O2. So we're pretty much solid there. Okay, and then we gotta just change up some stuff here. We gotta change up some stuff here. We gotta, oh, but the problem is maybe we have to flip. Okay, we also have O2 over here, and we have CO gas on this side. Exactly. So guys, we need to flip equation 2. So guys, step 1, let's flip equation 2 here. Why am I gonna flip equation 2? Step 1, I gotta flip equation 2. So why do I gotta flip equation 2, chat? Someone help me out here. So I gotta flip equation 2 here. Okay, and so my reactants become products and my products become reactants. So I have CO2 gas. I forgot to put the phase here. That's CO2 gas, okay, is going to equal, that's going to be CO gas plus 1/2 O2. Why did I do that, chat? Why did I flip equation 2? Okay, can you teach higher level physics like quantum, stat, and thermal? I wish I could. I wish I could. I can do classical mechanics and I can do E&M, but I can't do quantum, not yet. I can't do quantum, not yet. I want to add that to the list, but I stop at mechanics and electricity. So that's where I'm limited for now. But in the future, yes. Give me like a few more months to lock in, and then in the future I'll lock in for quantum to get the reagents on the right side before they cancel. Okay, perfect, exactly, right? So what did I do over here, chat? Notice that I took the negative here. So the reason I did negative was because I had to flip this equation here. So now that's really good because now I have my CO gas here. So I have my CO gas. Let's make that blue right over here. So now my CO gas is on the right hand side. So that's actually really good. That's what I wanted. But when I flip it, the rule is I have to take the negative of that H. So I'm going to take negative and then a negative 283. So that's going to give me a positive 283.0. Okay, so guys, drop a thumbs up if that made sense so far here. Okay, drop a thumbs up if you understood why I flipped my second equation and I took negative delta H, right? Does that make sense? Let me just pause here before I move on because this is the part where I start to confuse people sometimes. All right, Mark says thumbs up. Anyone else? Anyone else says thumbs up? Okay, can you do one more? We're not done. We're not done. We're still doing the example, okay? So the next thing I have to do is I have my CO gas, and then I have 1/2 O2 on this side, and then I have O2 on this side. So I think all I have to do is just add up, okay? All I have to do is just add up my first equation. So I'm going to do step 2, add first equation. add equation 1 once again. So I'm not going to do anything. This time I'm not going to flip it, chat. I'm just going to directly add it here. Okay, and then so now if I add that, so now I have negative 393.5. So now if I add that, what am I going to get, chat? What am I going to get? I'm going to get CO2 gas, okay? Because I'm going to add this equation and this equation now. So I have CO2 gas plus C solid, okay? So that's a problem because I have CO2 gas, okay? And then I have O2 gas, all right, on the left-hand side. So that's a little bit of a problem, but not to worry. Now I'm going to cancel out my right-hand side and a 1/2 O2 and my CO2 gas here. Okay, so take a look at that, chat. It's just like a math equation. Suddenly this turned into like an algebra equation. I have CO2 on the left hand side and CO2 on the right hand side. So I'm going to cancel out this. What else can I cancel out, chat? What else can I cancel out from this equation here? Notice I have C solid. That's what I want here. So that's actually a good thing. I want C solid, and that's up here. What else can I cancel out here? Okay, I got my CO, that was what I wanted to. But what else can I erase or eliminate here? Well, notice that I have my O2 gas here and then O2. So I'm going to eliminate one of these ones and then turn that into a 1/2. So at the end of the day, I got exactly what I wanted here. I got C solid plus 1/2 O2 gas, okay, reacts to form my CO gas plus my, what did I have here? That's it. That's just going to be CO gas. Now all I have to do is take my delta H's and sum those together. So that was a negative 393.5 minus a negative, which is a plus 283.0. So someone calculate that out for me. Someone calculate that out. Someone go ahead and take, what is 393? 393 negative 393.5. Okay, negative 393.5 plus 283. So someone go ahead and calculate that out for me. Okay, chat, did this make sense? Did this make sense, or am I confusing you, chat? If this made sense, go ahead and drop a thumbs up. Let me know what you calculated out here. Good job, Connor. Good job. Connor got it here. So we got negative 110.5. Chat, if everyone got negative 110.5, drop it down below. Christy, Licious, negative 110.5. Good. Kwanji, negative 110.5. We got to do negative twin. Make sure you add that negative because it's negative here. Okay? Went too fast? Okay, apologies. Went too fast? Apologies. Take your time, chat. Take your time. Okay, let's zoom out here. Let's see what we did. So what we did here was we had three given reactions. We had three given reactions. Here's number one. Reaction number one was up on top here. Now, reaction number two was right over here as well. And they said, hey, I gave you these two, but I don't know the third one. So the third one, I don't know what's that delta H. So we had to do some tricks. We had to use Hess's law. Oh, that's kilojoules. Thank you. That's kilojoules. Thank you. So what we had to do was we had to do some tricks to rearrange equations 2. So I noticed that on equation 3, I had CO gas. And I said, where do I have CO gas? Oh, that's equation 2. So the very first thing I did was I took equation 2 and I flipped it. So what do I mean by flipping it? I literally made the reactants and products on the opposite side. Okay, but when you flip it, you got to do a negative, chat. So when you flip it, you got to do a negative, and that's, excuse me, that's why I have a negative 283. And then when I added my equation 1, well, look at that. I was able to cancel out my CO2 gas. So I basically canceled out this CO2 with this CO2, and then I canceled out one of my O's. 1/2 O2 with one O2, got 1/2 O2. Okay, either way works, but then resulting reaction is reversed to the one to solve. Okay, so let me know if that made sense here, chat. So guys, how are we doing? Let's go ahead and do another quick poll. And again, if I still went too fast, don't worry, I will be posting this up on my YouTube channel tonight so you can review that. Okay guys, let's do that poll one more time. So same topic or new topic? I'm assuming that we might want to switch it up here. Same topic or new topic here. Let's get that poll. If you want to see another example for Hess's law, comment that happy face emoji. If you want to move on to electrochem, comment that crying emoji. 60 seconds up on the clock. And chat, we are about 55 minutes in today. We're going to keep it going for another hour and 5 minutes. Hope everyone's doing amazing this November. This is the first live stream of November. You already know I love the November vibes because it is nice and chilly. Ooh, okay, so we got basically equal votes, and suddenly we might switch topics here. Jay, thank you for the follow. Guys, don't forget you can join the Discord, which is 100% free, so you can join in on the Discord if you want to join in. Drop your questions, ask questions, and let me know what you guys want to go over. Okay, guys, so we got about 14 seconds left, and then guys, let me know, when are your exams? Is it I think mostly everyone finished exam season for now, and then you get like a little bit of breathing room, right? Usually it's like Halloween vibes, is like Halloween is like exam seasons, but now that Halloween's over, we get like a breathing room, right? We get like a breathing room, and then like beginning of December, end of November, like it's back to exam season again. So that's why we got to stay locked in, chat. Okay. Oh my gosh, I take it back. So someone has exams tomorrow. Okay, never mind. I guess it's just never ending. I guess it's just never ending. Okay. All right. So okay. So this is what we started last time, but we didn't quite finish. This is what we started last time, but we didn't quite finish. So this is perfect because we're gonna finish up this example here. So guys, we're gonna move on to a different topic. We're gonna move on to electrochem because I promised my electrochem peeps that we're gonna do this. And again, I'm gonna break this down. We're gonna do a college level problem, but I'm gonna break it down so whether or not you're in high school or college is gonna make a lot of sense. Okay. So we're gonna do electrochemistry. So once again, same question, chat. If you're ready to lock in for electrochem, go ahead and let me see those lock in emojis here. So go ahead and drop some thumbs up or some lock in emojis if you think that this is a good example to lock in for. Okay. Ooh, great question. So what even is electrochemistry and what does it pertain? Ooh, that's a really, really great question. So electrochemistry is the study of the chemistry involving electronic transfer. Ooh, what does that mean? So guys, what are some examples of electrochemical reactions? So what is an example of an electrochemical reaction that you might see in everyday life? Ooh, you might be using it right now. Okay, so you might be using it right now. So what's an example of an electrochemistry reaction here? Okay, so ooh, that's a nice name, Damilola. Ooh, that's a really pretty name. Hopefully I'm saying that right. H2O, redox reaction, lights, phone batteries. Yeah, I was thinking of phone batteries. Okay, anything that has to do with batteries, that's going to be electronics. Okay, electrochemistry. So basically, electrochemistry is the study of batteries. Okay, someone said ice. I don't think ice is going to be electrochemistry. Okay, it's gonna be typically involving like electronic transfers. So basically the most common example is a phone battery, right? Or a car battery. So does anyone know how a car battery works? Okay, we're gonna do an example here so we can break that down, and it's gonna be basically a redox process. So if you were here last time, we talked a little bit about redox here. So here's gonna be our example. We're gonna balance this out here. We're gonna have Cr2O7 2 minus, and this is gonna be in the aqueous phase, and Cl minus is gonna be in the aqueous phase as well. So this is gonna generate chromium 3 plus, okay, and then Cl2 gas. Okay, so we have an acidic solution of this compound here. Oop, I gotta stop showing this. I gotta stop showing here. All right, so we have this compound here. This reaction, we gotta balance this out. So we have chromates, Cr2, we have Cr2O7 2 minus, plus chloride yields Cr3 plus and Cl2 gas. Okay. If you have time, can you go over quantum numbers? Absolutely. So does electrochemistry involve redox reactions? Exactly. We're gonna exactly do redox reactions. Very good. Marco, very good. So we're gonna basically do lots of redox here. So let's do a quick review. So we talked about redox a little bit last time. So if you want to review that, check the YouTube video. Okay. And so what is gonna be oxidation versus reduction? So what is gonna be redox here? Redox reaction. So what is going to be oxidation of an element? Oxidation. Okay. Some people like Leo goes Gur. I like oil rig. I like oil rig. Okay. And some people like Leo Gur, and then some people like, I forgot the third one. Leo Gur, oil rig, and then you guys have another one. What's the third mnemonic for redox here? Okay, I'm not Gen Z, guys. I'm a millennial, so us millennials, we did oil rig. You guys have another one. You guys have another one here. Just remind me what that was. Okay. So oil is going to stand for oil rig. So oxidation is going to be losing, okay, losing electrons. So we're going to lose electrons. Okay, so we're gonna lose electrons. So and then reduction is gonna be gaining electrons. So that's what I mean by oil rig. So oxidation is losing electrons, losing here, and then reduction we're gonna gain electrons. Gain electrons here. So we have this reaction here. We're gonna see what is being oxidized and what is being reduced here. You guys do oil rig? I thought you guys have like another one. I heard someone say something a little bit weird that I haven't heard before. So I did oil rig, and then also you can do Leo Gur. I think is Leo Gur. I think Leo Gur. So that's oxidation, lose electrons. Oxidation, lose electrons, and then gain reduction. Reduction is gain electrons. Okay. So I agree. I like oil rig the best here. So we have CrO72 minus and then Cl minus. So we got to do two half reactions. So we're going to do this step by step. So it can be confusing the first time. So that's why we're going to do a step by step process. Okay, so if you do it systematically, you're gonna make your STEM life way more easier to understand. So step one, we're going to divide up into half reactions. Divide, we're gonna write out our main equation into two half reactions here. So our first reaction here is gonna be our CrO7 2 minus aqueous, and we're gonna see, oh, that basically just produced our chromium Cr3 plus aqueous. Okay, and then similarly we have so we have Cl minus. Let's leave a little bit of space here. I'm gonna say Cl minus, and that became, okay, Cl2 gas here. Okay, chat, so let's talk about our first one here. We have CrO7 2 minus and then Cr3 plus. So is this an oxidation reaction or is this a reduction reaction for the first one here? So guys, let's do a quick poll. So let's go ahead and see which one it is. Is this going to be oxidation or reaction? So let's do a quick poll here. I want to see how we're doing. The first reaction is, I gotta be quick. The first reaction is oxidation, reduction here. So guys, here's gonna be our next poll. So we got about 10 more seconds to think about that. And then I spelled reduction wrong. Okay, so the first reaction here, which says that CrO7 2 minus here yield Cr3 plus. So if you think that's an oxidation reaction, you're gonna vote for a happy face emoji. And then if you think it's a reduction reaction, you're gonna vote for a crying emoji. 60 seconds on the clock. Drop your votes now. Chan says just cheat, don't cheat. Kwanje says oxidation. Wait, so where does the extra oxygen from CrO72 go? It's gonna go to our, we're gonna form water. That's what we're gonna figure out. Okay, that's what we're gonna figure out. Stop saying cheat, guys. Don't cheat. Why would you cheat? If you cheat, you're gonna cheat yourself. How about that? Okay, Christy says Christy says happy. M says happy. Marco says happy. Everyone's saying happy. So how do you know it's oxidation? Okay. How do you know it's oxidation? Okay. We got one vote for crying. So guys, we have 15 seconds left. So if you said oxidation, why is it oxidation? Okay, 10 seconds left to vote. So this first reaction here is CrO7 2 minus, okay? And that's gonna be basically generating Cr3 plus here. So very good. So guys, we got 6 votes for oxidation. So y'all cook that up here. So if you voted for oxidation, you are correct. So go ahead and drop that party emoji. And let's talk about why this is oxidation. So remember, chat, the definition of oxidation means we're going to lose electrons here, okay? We're going to lose electrons here. And as you can see, our chromium went from, let's see, we have to do this here, and we got to be a little bit careful. let's see. We gotta be a little bit careful, chat. We gotta be really, really careful here. So let's see. Maybe we gotta double check that here. So we see that oxygen is typically gonna be -2 charge. Okay, so oxygen is gonna be typically -2. So then -2 times 7. Okay, -2 times 7 equals -14. So -2 times 7 equals -14, and then our overall is gonna be -2. So actually if I'm not mistaken, chromium here should be, and then so um plus 12 minus 14 equals -2. So chromium is actually plus 12. Uh-oh, this was a tricky question here. This is a tricky question here. So then we went from plus 12 to plus 3. So we actually gained electrons here. So chromium actually gained electrons. Okay, and then down here on the chlorine side, well, we went from -1 to +0. So here we lost electrons. Here we lost electrons. So this one was actually losing electrons. So therefore this one was actually oxidation, and then the top one was actually gaining electrons. Super tricky. So I got reduction here, guys. This is actually reduction here. Okay, let me know if that made sense here. So then what we have to do is balance the reaction here. losing CR is losing electrons. Okay. Can there be certain parts of reduction reaction that are both oxidation and reduction? Um that's a great question. Well, overall for redox, we're going to have one oxidation and one reduction. So no, we're going to have one reaction is oxidation and one is going to be reduction here. Okay? I'm getting brain cells back. Good. That's good. I'm glad you're getting some brain cells back. All right. So guys, now we have to go carefully one at a time here. We got to go carefully one at a time, and we have to basically add water here. So let's go to our reaction number 1, and let's write that down one more time. Is going to be Cr2O72 minus. So the first thing we have to add is water so we can balance out the oxygen. So we have Cr3 plus and we got to add some water. So how many waters do you think we got to add, chat? How many waters do I have to add to balance out the oxygens? Okay, is the plus 12 electrons from chromium or valence electrons? That's going to be the oxidation number for chromium, chat. That's going to be the oxidation number for chromium. Okay, so oxygen has a number of -2. So to balance that out, we have to do plus 12. Okay, so how many waters do we have to add over here to balance that out? How many waters do we got to add over here? So I see we have 7 oxygens. So I'm going to go ahead and add 7. I'm going to add 7 waters here on this side here. Okay, does everyone understand why I added 7? And so if I added 7 waters, now I have to add H's. So 2 times 7 is 14. So I got to add 14H plus here. So 14H plus Cr2, Cr2O72 minus. All right, so now we got to just do a little balance here. So if I have, now we got to balance out the charges here. So as of now, I have 14H plus, I have 14 plus 2 minus, and then I have 3 plus 0. So how many electrons do I gotta add and where to balance this out here? How many electrons do I have to add? Am I gonna add them to the left or to the right? Think of it as like a math class, guys. Think of it as like algebra. So if I have plus 14 minus 2 equals plus 3 plus 0, how many electrons do I have to add here? It's not going to be right, chat. Try again. It's not going to be right. Okay, good job, but try again. Okay, I need to add this. So let's do this math here. I basically have 14 minus 2 is a 12 equals plus 3. So plus 3 equals plus 12 equals plus 3. So do I gotta add it? So it's not gonna be the right, chat. Try again. So I can't add them to the right here. I have to add them to the left here. Okay, I have to add them to the left here. So I'm gonna add 6 electrons here because 6 has a minus charge of electrons have a minus charge of -1. So then 12 minus 6 is going to be plus 3. So plus 3 equals plus 3 here. So that's why I got to add my 6 electrons here. So for my overall equation, I have 14H plus plus Cr2O72 minus, and then plus 6 electrons here. Okay, so guys, let me do a quick check-in. How are we doing here? How are we doing? Are we still following along here? This is the part where I start to lose this topic. I need to figure out a nicer way to explain this topic because sometimes I lose folks right around this time. So if you're still following along, drop that thumbs up. And if you got a little bit cooked here, go ahead and drop that crying emoji. Don't be shy. Just drop a crying emoji to let me know that you got a little bit lost here. Okay, before we move on, how do we get the plus 12 from chromium? Okay, let's review that. So that was the confusing part for folks here. So on the chromium side, oxygen is going to have a -2 charge. Okay, oxygen is going to have a -2 charge. You got to memorize your oxidation numbers. Maybe we should have jumped into, maybe we shouldn't have jumped into electrochem until we reviewed redox. So guys, we need to memorize all the oxidation numbers before you can do we're trying to fly before we learn how to run here. So before you do electrochem, you got to review your oxidation numbers. So, and it's pretty here's my trick for you. So if this is going to be plus 0, then everything subtract 1, it's going to be like subtract 1, and that's going to be your oxidation numbers for that for that row here. So for example, this is going to be -1 usually. Okay, and then this is going to be -2. Okay, and then on this side, well, typically this is going to be well, now on this side it's going to depend. So now it's going to depend here. So now it's going to change depending on whether or not you have multiple elements here. So but the point is, oxygen, memorize that as -2. Sulfur is -2. Carbon is typically going to be plus charge. It could be +1. Okay, and then on the left hand side, what do we have? We have H is +1 here. H is going to be +1, and usually these ones are all going to be +1, and usually these ones are going to be +2 here. Okay, so everything on the left hand side is typically going to be +1. Everything on the right hand side is going to be typically -2 here. So the reason I got -12 plus 12 rather is because oxygen, we said -2. -2 times 7 is -14. So -14 plus 12 equals -2. So the overall charge is -2 on the right hand side. So plus 12 minus 14 equals -2. Okay, so let me know if that helped clarify just a little bit for that topic there. So if that made sense, go ahead and drop that thumbs up. How I got that plus 12. So one more time, got my -2 for my oxygen. -2 times 7 is -14. -14 plus 12 equals -2. Okay, so why plus 12? Because plus 12 minus 14 equals -2. So the overall charge, that's going to be the overall charge. So overall here is -2. Overall equals -2. So the overall charge is kind of like a math equation, chat. It's kind of like x minus 14 equals -2. So what's x? If x minus 14 equals -2, well, x gotta be what? How would you solve for x here? Okay, how would you solve for x? So it's an oxidation state that gives us the formal charge. Exactly. Yep, pretty interesting, right? Now you're learning. You're saying like it has to be equal to -2. That's exactly what I'm saying. That's exactly what I'm saying. Christy says, got it. Perfect. Okay, so now we're caught up there again. So that's how we got our oxidation number. Okay, so x minus 14 equals -2. And great. So now we have our balanced reaction. So once again, let's do a quick recap of how I balanced that. And so we said plus 7 H2O liquid because we have 7 oxygen. So this 7 comes from this 7. Okay, but then H2 is times 2. So 7 times 2 is 14. So 14 H's and 7 oxygens are balanced here. Okay, and then last but not least, we have to balance the charges. So we have plus 14 minus 2 is a plus 12. So plus 12 does not equal plus 3. Okay, plus 12 does not equal plus 3. So I need 6 electrons to balance that out here. So I need 6 electrons because 6 plus minus 6 plus 12 equals plus 3. So now we have plus 3 plus 3. So at the end of the day, I got 14H plus 6 electrons plus Cr2O72 minus yields my Cr3 plus 7H2O. Now how are we doing, chat? Let's do another quick check-in. So hopefully that made a little bit more sense when I explained it. Okay, but we're not done yet. That was only half of it. We're not done yet. We still gotta keep cooking. So go ahead and drop that thumbs up if that helped clarify some things. Okay, so go ahead and drop that thumbs up if that helped clarify some things. So we got to do the half reaction. For that was the reduction half reaction. Now we got to do the oxidation half reaction, which remember we said was Cl minus, okay, equals Cl2 gas, okay? So this one's going to be way easier. I think we should have started with this one, chat, because this one's going to be way easier. So if I have Cl minus plus Cl2 gas, well, first things first, I got to multiply by 2 so I can balance that out, okay? And then if I have 2 Cl minus here, how many? Okay, let's do a quick pop quiz. This is going to be an easy one now. Okay. Oh my gosh, wait a second. Yeah, that makes no sense. Wait, hold on a sec. What happened there? Wait a second. Hold on. Christy's right here. What happened here, chat? Minus 6 plus 12 is not plus 3. What did I do here? Oh no, chat, I forgot to balance out this 2. This is a 2 times 3. There we go. 2 times 3. 2 times 3. So plus 6. Okay, plus 6 times plus 6. Sorry about that, chat. Okay, plus 6 times plus 6. I forgot to balance my chromium. I apologize, chat. So my chromium needed a 2 there, so I can balance out that. Okay, so make sure you multiply that 3 by a 2 there in your notes. So that's plus 6 here. Okay, thank you, Christy. Thank you. Okay, so that was that mistake there. It was going to be plus 6. Okay, so but we're still going to get 6 electrons there, so we're still good. Okay, and 2 Cl minus equals Cl2 gas, so I'm going to need 2 electrons here on the right hand side, so I can cancel that out here. Okay, so this is my first half reaction and this is my second half reaction. I'm going to add all of that jazz together now. So I have equation 1 is going to be basically 14H plus, okay, 14H plus Cr2O72 minus, right? Plus 6 electrons plus 2 Cl minus, okay? So all I did was add everything together. So I'm adding everything together here. And then all I have to do is do here. We're doing redox reactions. We're doing electrochemistry, balancing redox reactions. Cr3 plus 7H2O plus 2 electrons, okay? And notice I can cancel out 2 of these electrons with 6 of these and 2 of these here, so that's going to give me 4 electrons. And I think we should be solid here. This is the half-step reactions from Gen Chem. Yep. And cool, I think we should be done here. At the end of the day, we got 14H plus, okay, plus Cr2O72 minus, plus 4 electrons, plus 2 Cl minus. Okay, that was our reactant side. And then Cl2 plus Cr3 plus 7H2O. And again, I keep forgetting that 2 there, so make sure you add this 2 right over here. And that's going to be plus 7H2O plus 3Cl2 here. Wait, why did I have 3Cl2? What did I miss here? I have to balance out. Oh no, hold on a sec. There's going to be, some of those were added. We got Cl, 2Cl. Why is that a 6? Hold on a sec, chat. Hold on. Cl2. Yeah, I basically have to multiply this by 3. I have to multiply this by 3 to cancel out here. This is going to be a 3 here, and then I have to multiply this by another 3. This is going to be a 6 here. Okay, and then we have 14H plus Cr2O72 minus plus 4 electrons. Gotta cancel out here. These electrons should cancel out. Okay, I didn't do that here. These electrons should cancel out here and give us 6 Cl minus. Yep. 6 Cl minus, and then that's going to be 3 Cl2 plus 2 Cr3 plus 7H2O. Okay, and then now we're finally done. Okay, so guys, hopefully that was not too confusing. We're about to do a recap here, but we're gonna basically understand one more time quickly here that this is the general process for your redox reactions here. We gotta go through one by one here and go step by step here. So once again, we basically started with our total reaction here, but this was totally unbalanced here. So this was our unbalanced reaction, overall reaction. So we had to do a set of two half reactions here. So we basically divided up into the oxidation and reduction step. So that was going to be CrO72 minus and then Cr3 plus, okay? And then similarly have Cl minus and Cl2 gas here. So what we did here was we added water. We added water to the first equation here. And then that way we can balance out our oxygen. And then we had to add H plus here to balance out that H on the right hand side. Okay, so when we added water, we can add our H plus back here. And then finally, we had to balance out our chromium and then balance out by adding electrons here. So that gave us our first half reaction was 14H plus CrO72 minus plus 6 electrons gave us 2 Cr3 plus 7 H2O. Okay, and then we had to balance out our second half reaction, which was 2Cl minus equals Cl2 gas plus 2 electrons. Adding everything together, we finally got our final answer, which was 14H plus Cr2O72 minus plus 6Cl minus equals 3Cl2 plus 2Cr3 plus 7H2O. Okay, and we are done. Okay, and we are done. Guys, try not to freak out. This is the general procedure for getting those overall reactions. Okay, try not to freak out. Just break it down step by step and keep practicing it. Okay, keep practicing it every single time. Let me know if this is helpful, chat. We still have 40 minutes for 2 days live stream. Let me know how we're doing here. Seems like a lot of people left, so I want to do another quick poll here. See what we're gonna do here, and let's see what's gonna be the next topic here. So we're gonna do the same topic or new topic, but then we got to figure out what that's going to be, chat. So guys, let's do another quick poll and see how we're all doing. Was this helpful or was this confusing AF? Let me know down below. And guys, let's get that poll up here. Can you do induction motors? Is that chem or is that physics? Okay guys, so we're going to do another quick poll here. Let's see how we're doing. 60 seconds on the clock. All right, so if you want to lock in for another electrochem question, go ahead and tap that poll on the top left-hand side and vote for that. 60 seconds on the clock, so vote happy face if you want to do another example for electrochemistry. Okay, or crying emoji if you said, you know what, that's enough. It's time to move on. It's time to move on. Oh, electrical engineering. Unfortunately, I can't do electrical engineering, twin. Guys, do you see the poll on the top left-hand side of your screen? Vote for your next topic here. Do you want to see that again or another example? And guys, we're going to do another 37 minutes here. We're going to do another 37 minutes here. So definitely let me know what's the next topic we should do. So some people said that we should continue. Okay, some people said that we should continue with another example. And then some people are saying that we should move on here, okay? So we got 2 votes for continuing this and probably going to do another example similarly. And then 1 is going to be another topic here. So guys, let's do another example for electrochem then, shall we? Ash, how you doing? I'm chilling, bro. How are you, man? I'm chilling. How's it going? I love the weather. I love the weather, guys. I think what we're gonna do is we're gonna do another electrochem example. It's gonna be a little bit harder. Actually, no, I think what we're gonna do is just a different type of question altogether. We're gonna do a different question altogether. So we're gonna do voltaic cells because that's gonna be really, really important. I'm gonna do voltaic cells. Okay. So we're gonna still do electrochem, but let's just talk about it. let's not do it too many calculations here. I just want to just talk about this one here because there's going to be like concepts here. So you're going to have some like multiple choice questions sometimes, right? Chillin' bro, just bombed the prepaid midterm. Oh no. What's that? Is that calc? Is that calculus? Okay, guys. So let's talk about electrodes, anodes, and cathodes. Okay, because that's gonna be really important. So we're gonna still do electrochem, but we're gonna talk about how to read the circuits here. So here's gonna be your solution, and you're gonna do a lab on this. So let me know if you already did your lab on this or you're about to do it. Oh, pre-calc. Oh, bro. Oh, I'm sorry you bombed your midterm, bro. What was on it? Was it really hard? Hey, bro, shoot me a text and then I'm gonna shoot you a text. We can work something out so that way you can do a lot better. Okay, so here's gonna be our electrode. Guys, we're gonna go ahead and do this bunch of word problems. Bro, I got you. Yeah, those are hard. So, yeah, let's see what we can do for the next one, you know? When's the next, do you have another exam coming up? Or is that it? Are you just done? Maybe do you have I'm sure you have a final, right? When's your final? How many more weeks until your final? Okay, so here's gonna be our voltmeter here. It's gonna be basically we're gonna draw a circuit here. Okay, so here's our circuit, and then here's gonna be our voltage switch. And this is typically gonna be a voltage meter just like this. Okay, and let's see here. So we're gonna have our electrons flowing like this. Okay, and the electrons are gonna flow this way. So this is gonna be a zinc anode. This is gonna be a zinc anode. 5 more weeks, first week of December. Okay. Okay, okay. Okay. Is it too late to drop it? Maybe that's the wise thing to do. If you need to drop it, you can save your grade. Retake it next quarter. Okay, and then here's gonna be what's called a salt bridge. So guys, we're gonna draw out this anode and cathode. So guys, we're gonna basically draw out, this is gonna be sodium nitrate coming in here, and then this is gonna be Na plus going to the right side over here. Okay, so now this solution is gonna be filled with sodium nitrate. Okay, so sodium nitrate is going to go into this, and then copper 2 plus is going to feed over here. This is going to be the copper cathode. And so this is how this is going to be the copper cathode. This is how we're going to read this chat. We're going to say that this is zinc is coming off of here, zinc 2 plus, and then it's going in here, plugging that up here, and then NO3 minus here. Okay, so what could they ask you? I wonder if anyone has any practice questions. So they could ask you, well, for instance, which direction is the electron flowing here? So in this case, we're going from the zinc anode all the way to the cathode here. So the electrons are flowing from, in this case, from left to right. They're going from the anode. So the anode is going to be the one that is negatively charged here. Okay, and we're going to release our positive ions, and then the cathode is going to be the one that is absorbing these electrons here, so it's going to have that positive charge here on the right hand side. And then what else might they ask you? They might ask you what is going to be the function of the salt bridge. So the salt bridge is going to serve to balance out the charges on the left hand side with the right hand side. So as you can see, this solution of sodium here, sodium nitrate, is going to be balanced out by this blue thing. I'm going to color this in blue. This blue thing is going to be called the salt bridge. Okay, and then that's going to be called the salt bridge. I had to finish some homework. Thank you for helping us out. Of course, my pleasure, twin. Good luck. Considering dropping it because I have 17 units, but they delayed me for science, like bio. Okay, okay. Hope your exam for physics was good. What is this for? This is going to be for Gen Chem. This is going to be electrochemistry here. And yeah, guys, that's pretty much going to be the main idea. The last thing you have to do is write the equations here. So the equations are going to be the formulas, rather. The chemical formula: zinc solid was Zn2 plus and 2 electrons. And then we're going to do Cu2 plus aqueous plus the 2 electrons gives us the half reaction here for copper solid. So make sure you understand how to draw out the voltometer, because they are going to either ask you to draw it or label it, or they're going to give you the diagram and you're going to have to answer questions regarding the diagram. So again, it's important that you understand that this is the anode, here is the minus charge, and then the cathode here is a positive charge. Okay, and let's see what else they would ask us for. Yeah, the movement of the cations is going from the movement of the electrons is going from the anode, okay, up to the cathode there. All right, so guys, let's do another quick check here. Let's do another quick check. I'm going to ask you guys another question, which is basically going to be, what's the next topic here? Okay, what's the next topic to focus on here? So let's see if we want to switch it out of Gen Chem. Let's see if we want to switch out of Gen Chem. Do you have anything on the Discord about addition on alkenes? Yes, if I'm not mistaken, Juan, I think I tagged you, bro. I think I tagged you on the addition reactions. Okay, so make sure you check the Discord for that. If not, I can tag you again. Okay, so we're going to do same topic. We're going to say Gen Chem, or we're going to say enough Gen Chem for today. A new topic. Please end this. And let's see if we're going to switch out of Gen Chem. Saint says stick to Gen Chem. So guys, if we're going to do Gen Chem, what's going to be the next topic? I think that was enough for Electrochem. Maybe we can do either gases. I think the next topic I saw was ideal gas law. Okay, so we got 60 seconds on the clock. So guys, if you want to stick to Gen Chem, tap the top left hand side of your screen, tap the pull button, and tap happy face if you want to do Gen Chem, or crying if you want to do a different topic altogether here. Nayeli, thank you for the follow. Zane says gases. Shorty says SN1. Focus says new topic. Are they the same for alkynes? Oh, did you say alkynes or alkenes? Oh, my bad. Okay, no, there's gonna be different ones. I read that as alkenes. Okay, I'm gonna send you one for alkynes. Juan, if I forget, please tag me, bro, if I forget. But I'm gonna send them to you after this for alkynes in the Discord. Guys, we got 10 seconds left. Vote happy for Gen Chem. Same topic for Gen Chem, or crying if you want to switch it out. Okay, 5 seconds left. Okay, guys, so Gen Chem was just cooking all day today, so we're going to just stick to Gen Chem. The next topic we're going to do is ideal gas law. Okay, so this is going to be probably one of our last topics for today, so make sure you log in today for ideal gas. Okay, and then let's see what we're going to discuss here. So ideal gas law here. Okay, so the ideal gas law is going to be given by what formula, chat? What's going to be the ideal gas law? What's the main thing we got to do? Jackson says ideal gas is goated. True. So guys, what's going to be the main formula for ideal gas here? Okay, perfect. So PV equals nRT. All right, awesome. Yeah, absolutely. So then we have PV equals N times R times T. So then what is going to be each of these going to be corresponding to? So what do each of these terms mean? And how do we use this equation? How do we use this equation here? This is the most important equation you're going to need for ideal gas law. Okay, actually, I don't want to box that. I want to keep this up here. So what is pressure going to stand for? And what are the units for each of these? So what are going to be each of the units here? So P is going to stand for what? And what are the units here for each of these terms? Okay, so P is going to stand for pressure here, and that's in units of atmospheres, right? So P is going to be the main thing that we're going to focus on now. is going to be P stands for pressure, and it's in units of atmospheres. So they're either going to tell you it's 1 atmosphere, or they're going to tell you what the pressure actually is in the system. Okay, and then we're going to say V stands for what? What is V going to stand for? Okay, cool. So volume is going to be in liters next. Okay, so volume is going to be in liters. And then, guys, let me give myself some more space here. Okay, and then once you learn how to use the equation, that's how you can answer all the problems. Okay, so V is going to stand for volume. Okay, and that's going to be in liters. Okay, so PV equals nRT. And then, yes, it could also be in torr. Exactly, it could also be in torr. And then N is going to stand for what? Okay, good. So N is going to stand for moles now. Perfect. What about the R gas constant? What about the R gas constant? Yes. Okay, it can also be in torr. Okay. What about the R gas constant, guys? What is the value of the R gas constant here? And so we have to learn how to use the equation now. We have to learn how to apply and use the equation. And then what is R going to be indicated by? Okay. Awesome. Came across my FYP 5 days before the exam. Okay, awesome. So does anyone know the gas constant? So T is going to stand for temperature, and it's typically going to be in Kelvin, okay, or Celsius. We got to convert that to Kelvin though. And then what is going to be the R gas constant here? So we're going to say the R gas constant is going to be 0.08 wait, what is that again? I actually forgot. 0.0628. What is the R gas constant, chat? I can't believe I actually forgot, guys. I used to memorize this in my blood. R gas constant here is 0.08 liters times atmospheres per something something. Okay, 0.08. I'm getting a little bit confused. Everyone's tricking me here. 0.08201, 0.0821 here. Liters atmospheres per mole times Kelvin. Someone said per something something. It's per moles times Kelvin. Okay, perfect. So each of these terms are going to be given to us in the example here. So you're going to say, for example, like a pressure or a volume here. So whatever they don't give us, that's what we have to solve for, okay? So we're going to have several cases here. Whatever they don't give us, that's what we have to solve for. And so let me give you guys some examples here. So let me give you guys some examples here. I'm going to give you an example where, for instance, let me just find an example here, chat. Bear with me one sec. All right, so we have calcium carbonate. Okay, we have calcium carbonate, and so it's gonna decompose into carbon dioxide. So we're gonna have carbon dioxide gas, okay, is collected in a 250 milliliter flask. Okay, in a 250 milliliter flask. Okay, and then after the decomposition is complete, the gas has a pressure of 1.3 atm. So the pressure is given as 1.3 atm, and a temperature of 31 degrees Celsius here, 31 degrees Celsius. So we have to calculate how many moles of CO2 gas were generated. Okay, how many moles of CO2 gas were generated here? So that's going to be each of these here. So guys, what's going to be the very first thing we have to do? What's going to be the very first thing we need to do in order to calculate the moles of CO2 gas generated here? So if we have 250 milliliters and a pressure of 1.3 atm, then and when our temperature is 31 degrees Celsius, then guys, what's going to be the very first thing we have to calculate here? So always write down what we have given here. So let's write down what's given. Well, we know the ideal gas law equation, so that's PV equals nRT. And then we have the pressure here. So the pressure is going to be 1.3 atm. Pressure is going to be 1.3 atm. The V for the volume is going to be 250 milliliters, but we have to convert that to liters. Okay, so that's actually going to be 0.250 liters. Okay, and then the temperature is going to be 31 Celsius, but we don't want that in Celsius, chat. How do we convert Celsius into Kelvin? How are we going to convert Celsius into Kelvin? Okay, good. Juan says milliliters to liters, so we got that. So I just converted my milliliters to liters, and then convert to Kelvin. So chat, how do we convert to Kelvin? Good. So we're going to add 273. Good job. All right, Ariani, and address, we got to add 273. So what is 273 plus 31? What is 273 plus 31 here? That's going to be approximately 304 Kelvin. So perfect. So now I have my pressure is in atm, and my volume is in liters, and I also have my temperature and my R gas constant here. So I'm going to rearrange the formula here. So I want you to get comfortable rearranging the formula. This is PV equals N times R times T divided by, okay, the R times T divided by R times T. So I'm going to cancel out R times T and be left with my N, okay, is PV over R times T. So this is my new equation here. Okay, very good. So King, I'm gonna have to drop in my class. I'm so sorry. You didn't fail me, twin. It's okay. Whatever you do, you're gonna probably you're probably doing the best thing for yourself right now. Okay? And don't even feel bad about it, okay? I will still be here for you if you decide to retake it. Okay, and now I'm gonna plug these in, chat. I'm gonna basically plug in my values. I plugged in my pressure times that here. Okay, this is 1.3 atm. This is 1.3 atm. Okay, guys, sometimes it's a little bit harder than we realize. We just have to log in a little bit sooner, and that way we can get better over time here, guys. So that's 0.08 206 206. Okay, that's going to be liters times atmospheres per mole times Kelvin. So then I have to also divide by my Kelvin here, which remember we said was 304 Kelvin. Okay, and then that's going to be Kelvin cancels out, our ATM cancels out, liters cancels out. And guys, mathematically speaking here, we should get everything in terms of moles. So someone please calculate that out here. Someone please calculate what is 1.3 times 0.250 divided by 0.08206 times 304. Totally failed my thermochem. Oh no, I feel like it's easy once you know how to rearrange the formulas. Exactly, right? Once you know how to rearrange the formulas, then you can see clearly that all we're doing here is basically just algebra here. So all we're doing is a little bit of math. 1.3 times 0.250 divided by 1.3 times 0.250. Okay, divided by here, that's going to be divided by, okay, 0.08206 times 304. So I got, okay, I got 0.013 moles of CO2, and that's going to be the final answer here. All right, guys, how are we doing here? Let's do another quick check-in. Guys, if this is making sense here, we basically just did ideal gas law. So let me know if there's any questions about how this works. Okay, if you are understanding this and you're so far so good, go ahead and drop that thumbs up. Guys, we just hit 10K likes today. Thank you so much for the 10,000 likes. We got a couple gifts, 35 new followers. We're going to keep it going for another 15 minutes. So now's your last chance to ask any more questions regarding Gen Chem, Math, Physics, or Calc. 0.013 moles. Awesome, Jackson. Good work. Good work. I forgot how to find change in enthalpy. Actually, that was something we just did earlier today. So if you missed the earlier part of the live stream, don't worry. I'll be posting that later tonight. I'm learning this right now in engineering. Ooh, what kind of engineering are you, my friend? For the P1V1 over N1, T1 equals P2V2 over N1 T1 formula, we only use that when we are asked to find the final of sum. We only asked to find the final of sum. What is the z factor? The z factor is exactly going to be over here. So let me see if I understand your question, Ariani. So we have P1 V1 over T1 equals P2 V2 over T2. So you're typically going to be using this equation, which is the overall ideal gas law, when you're identifying the change from one species to another, so from one phase to another. So for example, if they ask you, okay, the initial pressure or the initial volume changes to P2 or V2, and you want to find the final temperature, that's how we use that equation there. Okay. Now, the z factor, if I'm not mistaken, the z factor I think is defined. This is in chemical engineering, so quick side note for chemi. The z factor is defined as PV over RT, if I'm not mistaken. So this is going to be used for estimating the partial pressure, I believe, of gases, or it could be used to define any thermodynamic quantity for ideal gases in thermodynamics. So that's going to be a this is not required for Gen Chem. This is only for chemi or mechanical engineering. Okay, so guys, that's gonna be a quick side note for thermo. Can you go over the ideal gas law again real quick? Okay, so let's do a quick recap. So the ideal gas law is the following. It says P times V. Okay, so P stands for pressure, and that's gonna be in atmospheres. Okay, if it's in another unit such as torr, make sure you convert it properly using your equation sheet. And then V is going to be in volume, that's in liters, equals, N is going to stand for moles. Okay, so that's what we just solved for in our example. We're going to solve for moles. R is the R gas constant. Please, please, please memorize. R equals 0.08206 liters atmospheres per mole times Kelvin. Okay. Can you tutor intermediate microeconomics? Unfortunately, I cannot tutor microeconomics. And then temperature is going to be measured in Kelvin, okay? So if you have something in degrees Celsius, make sure you convert it to Kelvin. So for example, we saw that CO2 gas was collected at 250 milliliter flask, and the pressure was measured at 1.3 atmospheres when a final temperature of 31 Celsius. So we had to calculate how many moles of CO2 gas were there in the system. So we use the equation PV equals nRT, and so we know we have pressure here. Pressure was 1.3, so pressure was 1.3 atm. Volume was 250 ml, but we have to convert ml into liters. Okay, 250 liters. Okay, and then temperature was 31 degrees Celsius, which we added 273 to get 304 Kelvin. We basically did a little bit of rearrangement math. We rearranged our PV equals nRT by dividing both sides by RT, so that way we can cancel out our RT on both sides. Okay, and we basically said that N is equal to PV divided by RT, and plugging that in, we got an answer of 0.013. Okay. Ooh, good question. When do you use Raoult's law versus Henry's law? Ooh, that's a really good question. So Henry's law is typically going to be for solutes in solution. Raoult's law is typically going to be for your partial pressure of your gases. So that's a little bit more general. But Henry's law is a specific case where you have a concentration of a solute in a solvent. I believe I added some ideal gas problems to the website. Ooh, I definitely gotta be checking that out. I love how people are acting, learning in here. I know, isn't it awesome? Guys, that's why everyone should join the Discord, so that way you can drop in your questions here. Oh, Jackson added here. Raoult is for mixtures. Henry's is for gases dissolved in liquids. And you know what? I should have said it like that. That was a way better explanation. That was a way better explanation of what I said. Okay, so I'm a disgrace to the the chemical engineering community here. So I should have said exactly what Jackson said. So the Raoult's law is gonna be for your it's gonna be for your um uh your vapor liquid equilibrium here. So if we have a liquid here, and this is gonna be vapor, and so Raoult's law is gonna be given by XIP is gonna be the partial pressure here. So that's gonna be Raoult's law here, and then for the gas is dissolved in the solvent here. That's going to be our Henry's law here. So guys, I'm blanking out on Henry's law. We're going to have our H here. Guys, let's get Henry's law real quick. I believe this should be our H times Xi for Henry's law, if I'm not mistaken. Someone correct me if I'm wrong here. Okay, guys, I'm kind of cringing because this is a really, really basic chemical engineering thing, and I'm totally forgetting my fundamentals at the moment. So I'm kind of cringing on myself because it's a very, very important chemical engineering. So if my professor sees this, they're definitely gonna roast me here. Okay, so I gotta get my Henry's law accurate here. And we're going to say that's going to be the concentration is equal to the constant times the pressure here. This is going to be concentration times the equals the H times the pressure here. So this one is Henry's law. There we go. Okay, so guys, I'll make sure to review that because that one's super important for me. It is going to be Henry's law versus Raoult's law. I would join, but I'm an econ and politics major. Oh, got you. Well, you can still join if you want, Kiki. Okay, appreciate you. Yeah, HXI equals partial pressure. Yeah, that's gonna be something like that, right? Add the Antoine and Clausius Clapeyron. So the Anton equation is how we get PI sat. So Anton is how we get PI sat. And guys, oh my gosh, I'm totally blanking out. I used to do this all the time. Anton equation. Oh my goodness, it's been a minute, guys. I'm definitely really rusty. Hold on a second. Hold on a second. Antoine equation. I'm definitely really rusty here. A plus Z T. Oh my gosh, guys. I'm totally rusty on my thermo here. Is the log of the P, the log of the pressure is equal to A minus B over T plus C. So you got to look in your textbook for these A plus B, A, B, C values here. And then you can just look this up for each gas. And that's how you're going to get the pressure at that temperature here. Okay. When my professor said Raoult, I thought he said Raoul. I was sad to find out he's not a Latino baddie. If you don't mind me asking, have you thought about becoming a professor? I have thought about becoming a professor. I originally wanted to become a chemical engineering professor, and that's still an option for me, guys. Okay, that's still an option. But at the moment, I'm doing private tutoring, and I really love private tutoring. Oh, thank you for the hand heart, Kiki. Super appreciate you. Okay. How do I find the liquid fraction composition when dealing with mixtures in VLE? Okay, now we're definitely in the thermal regime. So So now we're talking about thermo here. Now we switch from Gen Chem to thermo, which is really cool. That's fine. So we're going to use the short answer is going to use Raoult's law. So you're going to use your table to get the saturation pressure using the ABC terms from Antoine's equation. So you're going to check a table in your textbook. Okay, that's going to give you your ABC terms for your saturation pressure. So then you're going to take the 10 to the power of both sides to get the saturation pressure. You're going to say PI sat equals 10 to the power of A minus B over T plus C. And then you're going to plug that into the right hand side here. This is going to be equal to XIP equals YIP sat here. So we're going to say that XIP equals YIP sat. So now you're going to plug in your saturation pressure here. And that's how you're going to get your vapor liquid equilibrium for your XIP sat. Now do recall that the sum of the mole fractions for your liquid vapor is got to be equal to 1. So x1 plus x2 is equal to 1. And then y1 plus y2 is equal to 1. So first things first, you got to calculate that out for one of them. And then you can finish by balancing that out to get your equation for the second one. Now, what other equations are you going to need? You're going to also incorporate Yeah, if you have any other additional equations, then you're going to incorporate that to calculate and reduce the degrees of freedom here. So that's going to help you get your x1 and your y1. Okay, so guys, this is a thermodynamics question here. Great question here. Antoine is more accurate than Clausius-Clapeyron. Exactly, right? Pretty sure Antoine is an empirical fit or something along the lines of that. That's exactly right. Yeah, I'm pretty sure Antoine equation is empirically um, calculated data that the engineers did for us back in the day. Thermo is the worst subject for mechanical FE. Any suggestions or resources to get better at it? Well, I don't know about mechanical thermo. This is more like chemical thermo. So mechanical engineering thermo, I'm assuming you guys do more like entropy, um, enthalpy, like you guys do like heat engines and things like that. So number one is, do you have a textbook? Okay, you're gonna have to use a textbook here, and if you need any, I'll drop some in the Discord. Okay, so I drop all the textbooks in the Discord. So that's gonna be your first thing, is do the textbook problems. Okay, learn how to do all the energy balances. So you're gonna have to do enthalpy, internal energy, entropy, and basically pressure energy. Okay. When do we use Clausius-Clapeyron instead of Antoine? So Clausius-Clapeyron is going to be mostly used for when you have pressure versus temperature. So I typically don't use that unless they give you delta H. Clausius equation. Clausius-Clapeyron equation. So this one's going to be used in terms of delta H. So if they give you delta H, then that will be a little bit more useful. So we're going to use, this is called the Clausius-Clapeyron equation. It's going to be equal to ln of P2 over P1 equals negative delta H over R. And then you're going to say 1 over T2 minus 1 over T1. So I typically don't use this equation that often unless I want to get my pressure too between two phases. So that one's like not as common compared to your Raoult's law. Raoult's law is going to be your main most important equation in thermodynamics for chemical engineering, because that's how we're going to get our vapor liquid equilibrium here. So we have xi, okay, and then yi here is going to be your two main constants that we're going to try to calculate for equilibrium. This topic is my favorite. Interesting. I know Jackson is the thermo goat here, guys. Jackson is actually really goated here. Clausius is more for quick results. Anton is necessary for utmost accuracy. Exactly. Yeah. Yeah, I agree with that. Yeah. Clausius is just to have like a quick idea, but it's a good model for low pressures and low temperature, or average pressures and low temperatures. But once you get high pressure regime or low pressure regime, then it's going to start to fail and deviate from the accuracy here. So not highly recommended that you model with Clausius-Clapeyron every single time. Okay, and that's going to be dependent whether, again, you're taking your chemical engineering thermodynamics or mechanical engineering thermodynamics, or in real life. So in our case, our friend Jackson in the chat is actually using these equations in real life for his experiments in the lab. Okay, so he's the thermo expert here, so you can ask him all these thermal questions here. Clausius is based on delta H2, yeah, so Anton is based on empirical data set, exactly. Okay, but delta H is empirical as well. How do you find pressure in equilibrium? How about quotients, partial pressure? The formulas confuse me. Okay. Oh, fellow chemi. So guys, to use these equations, we kind of ran out of time, so maybe we'll do this next time. So maybe make sure you ask me tomorrow. So maybe I can show this tomorrow. I can prepare some videos on this tomorrow. This was one of my favorite things to calculate. So the way it usually works is you have your mole fraction. Let's break that down. Okay, you have xi p equals yi p sat. So this is going to be your liquid mole fraction, and then yi is going to be your vapor mole fraction. So they're either going to give you x1 or x2, and then they're going to ask you to get the equilibrium pressure here. So then you can solve for yi pi sat p sat divided by xi. So you need to solve for it using number one, the temperature. So if the temperature is given, you can solve for the temperature using Anton's equation. Plug it in here and then get that first component to get p sat. And then for yi versus xi, they're typically going to give it to you, or you can look on a graph. Okay, so if you have like a graph, for example, if you have y versus x, then you might see where that would lie on that graph, and then you can help identify between, it's going to be between 0 and 1, okay, based on that composition here. Okay, do you do physics too? Absolutely. Yo, Helena, Dawa's girlfriend. All right, guys. So yeah, I got you on physics. Thanks a lot for joining. Pretty much gonna end it here, but I will be back tomorrow, the usual time, 6 o'clock every single week. Guys, here's the website where you can join in on the Discord. You can join up on the live stream. You can join on the Discord for totally free. Drop your questions, and yeah, guys, sign up for tutoring if you need any help. You can sign up for the first session is 100% free. And yeah, guys, I got you on all these STEM subjects every single week, Monday through Thursday around this time, 6 o'clock PST. And yeah, guys, let me know, shoot me a DM or shoot me some practice problems, or join in on the Discord if you need any further assistance. Thanks a lot, Jackson. Thanks. Shouts out Hugh Academy. Yeah, check out the resources. Okay, let's just check out the resources real quick. So I think he added some ideal gas here. So let's see, chemistry. Ooh, and then Jackson wrote some for unit conversions. Okay, awesome. Oh, okay, fire. This one's new. Oh, okay, fire. We're gonna try out some of these. Okay, so we got some new ones here. Super awesome there. Thank you, thank you. And let's see the ideal gas law here, practice set. Ooh, okay, we can definitely check out these tomorrow. Okay. Yup, yup, yup. Okay, a fire. We can definitely check out these. We can definitely check out these tomorrow. I didn't know we had these. Awesome. Awesome, awesome. Relative humidity. And yeah, guys, I gotta lock in today and drop some of these myself. Oh, look, you already wrote the Antoine equation here. Perfect. Perfect, perfect. All right, guys, I'm pretty much gonna head out for today. And then I'll see y'all tomorrow. And stay safe, my friends. Peace out.